Hello friends and followers, welcome back to the channel. In today's video we continue with our series on aircraft propeller system, and in this video today we are going to be looking at the pitch change of a propeller. We'll define what is propeller pitch, we'll look at the purpose of the pitch change of a propeller, and we are also going to list the different propeller pitches that are used or that can be found on a propeller system. And finally, we look at how this pitch change is achieved on an aircraft. So welcome and enjoy the video. The propeller pitch is the distance that a propeller will move forward in one revolution. For example, if you have a propeller and the blade number 1 is at the 12 o'clock position. As the propeller starts rotating and the aircraft is moving forward, as this blade number 1 rotates the entire 360 degrees going back to the 12 o'clock position where it started, the distance that the aircraft will have moved forward during this rotation is what is known as propeller pitch. Now, if the pitch of the propeller is changed, this distance that the aircraft will move forward in one revolution is also going to change. And this is the reason why the propeller pitch change is very important to an aircraft operation. The pitch change of a propeller is done so that the propeller and the engine will give the best performance for a particular phase of flight. For example, for takeoff, there's a pitch that is suitable for takeoff. For cruise, there's also a pitch which is suitable for cruise. The pitch change of a propeller is essentially the change of the propeller blade angle. The blade angle of the propeller is the angle between the propeller plane of rotation, which is an imaginary vertical plane which is perpendicular to the longitudinal axis of the aircraft. That is the plane of rotation. And the chord line of a propeller is the line that joins the leading edge and the trailing edge of the propeller. It cuts across the length of the propeller from the leading edge to the trailing edge. That is what is called a chord line. Now, the blade angle is the angle between the propeller plane of rotation and the chord line of a propeller blade. Well, when we do a pitch change of a propeller, what we're changing is the blade angle of the propeller. Now, the reason for changing the propeller pitch or varying the propeller pitch is to enable the engine to give an optimum performance for a particular phase of flight. For example, during takeoff, a small blade angle is required, as this enables the engine to rotate at higher RPM, therefore producing high power which is needed for takeoff. But in this condition, this aircraft speed is lower compared to other blade angles which might be suitable or which are suitable for other phases of flight. In cruise, the blade angle is slightly increased, and this increases the load on the engine, and as a result, the engine RPM is slightly reduced, but this configuration gives a higher speed compared to the previous configuration that is used for takeoff. As per this definition, as per this example that I've just given, you can see that one configuration is suitable for takeoff and might not necessarily be suitable for cruise, and the other configuration is suitable for cruise which might not be suitable for takeoff. And that is the reason why the propeller pitch is varied during flight to enable the engine to give the best performance for a particular phase of flight. There are 4 propeller pitches that can be used on an aircraft. We have the fine pitch, we have the coarse pitch, we have the reverse pitch, and we also have the feather pitch setting of a propeller. The fine pitch propeller is when the propeller blade angle is set at a small angle. This is used mostly on takeoff, and the reason for this is, like we mentioned earlier, that at this small blade angle, the load on the engine is reduced, and as a result, the engine can rotate at high RPM and produce high power, and this is suitable for takeoff. The next pitch is coarse pitch, which is a slightly larger angle compared to the fine pitch, and this coarse pitch is suitable for cruise because at this angle the load on the engine is slightly increased, and as a result the engine RPM is slightly reduced. But this comes with an increased aircraft speed, which is what we need during the cruise phase of an aircraft. The next pitch is the reverse pitch. During reverse pitch, the blade angle is slightly set at a negative angle, and this assists in stopping or bringing the aircraft to a stop after landing. And the next pitch that we're going to look at is the feather pitch. The feather pitch, when a propeller is set to feather, the chord line of the propeller is set at 90 degrees to the plane of rotation. And at this feather position, what we are basically doing is we are reducing the drag being produced by the engine. And this one, on some aircraft, especially the free turbine aircraft, this setting is used for engine startup. But the other function of the feathering of the propeller or the feather angle is to enable drag reduction during flights, especially on multi-engine aircraft. When the propeller is set at that angle, it creates less drag than a windmilling propeller, and this assists in flight whenever we have an engine failure. We don't want to have too much drag being created by the engine as it windmills. That is the reason for feather setting on a propeller. Now we are going to look at the ranges or the blade range in which we can operate a propeller. We have the alpha range, and we have the beta range. The alpha range setting of a propeller is the range that runs from the flight idle to the maximum RPM, which is at the superfine angle. And the beta range is from the flight idle setting going backward up to reverse. Now the difference between the alpha range and the beta range is this. During alpha range, the propeller pitch variation is done using a propeller lever. There's a lever in the cockpit that is specific for adjusting the blade angle on some aircraft. Though on some aircraft this is done automatically by different components that are fitted on a propeller system. So whenever you use this lever to vary the blade angle, and this happens in flight, you are operating the propeller in the alpha range. But for a beta range, the power lever is used to change the blade angle, and this one goes from the flight idle and up to reverse. From flight idle or ground idle to go to reverse, you use the power levers. You don't use the propeller lever, and this is the difference. The pitch change in the beta range is done using the power lever, while in the alpha range the pitch change is achieved by the use of the propeller lever. Another difference between the beta range and the alpha range is that in the beta range it is the pilot who controls the propeller pitch of the propeller, while in the alpha range it is the propeller governor that controls the propeller pitch of the propeller. Now next we're going to look at ways in which this propeller pitch change is achieved. There are two mechanisms that can be found on an aircraft. There is a moving piston mechanism and there is a moving cylinder mechanism. For a moving piston mechanism, we have a piston inside a cylinder, which is basically the propeller hub. And in this cylinder, we have a piston that moves either to the front and back, and as it moves from front to the back, it changes the propeller blade angle. The next configuration is the moving cylinder. In this configuration, unlike the first configuration, the cylinder is mounted externally and the piston is not inside the cylinder. So in this configuration, it's the entire cylinder that moves, and as it moves, the propeller blade is changed. Unlike the first configuration, in which the piston inside the cylinder moves, and as it moves, the propeller blade angle is changed. We have two ways in which the propeller blade pitch change can be achieved. There is a single acting piston or single acting configuration, and two, there is a double acting configuration. In a single acting configuration, we have a piston which moves in one direction and is moved in this direction by oil pressure, and the movement to the other direction is achieved either by the use of a spring force or some sort of momentum that is created by the flyweights which are mounted on the propeller that moves the propeller in the other direction. So the oil pressure only moves the piston in one direction, and this is the reason why it is called a single acting propeller. In a double acting propeller, the movement of the piston in both directions is through the use of oil pressure. Thank you for watching this video till the end. We humbly request you to subscribe to the channel if you haven't subscribed to the channel, and to turn on the notifications so that you'll be notified every time we post a new video.